Hello and welcome everyone. My name is Avi Bhatt and I lead the global data and analytics team for architecture at McDonald's. McDonald's is a globally recognized and a known brand which operates in more than 100 plus countries. However, let's look at McDonald's from a numbers perspective. What does it mean from a numbers perspective for McDonald's? At McDonald's, today we serve more than 600 different variety of menu items with 71 million orders that get processed on a daily basis in 100 plus countries. If you look at that, approximately that equates to feeding 1% of the global population on a daily basis. That is to articulate the scale and the complexity at which McDonald's operates today, right? Now, if you couple that with the changes that in the business model that McDonald's is going through, any change implementation is not easy. It takes a lot of effort in terms of coordination and to make sure it's a success. However, we are still are reacting and changing our business model in terms of what the expectations are from customers. Our customers are going more digital and we are responding for that. We've launched McDelivery, where you can get your McDonald's food delivered to you easily. We have a global menu restaurant in Chicago, which really brings in new global menu items from different places in the world, and that all of that equates to providing an experience to the customer that is different and unique, but also making sure that we do not compromise on the quality and the service of the food. Right? So if you look at the scale and the change in the business drivers that McDonald's has, think about what that means from a data challenges, right? As we have an on-premise solution and a system, we had data silos. And one of the biggest reasons for that is our geographical different locations where we are spread across. The collection and the storage of data when you're in an on-premise solution is hard. Limited scale. Scaling our infrastructure to add new servers, new capacity, took weeks and months, if not more. From an analytics perspective, we did great in terms of figuring out what had happened in the past and more of a descriptive analytics, limited by the technology that we have. From a self-service perspective, yes, we collected the data, we had the insights, but accessing the data was hard for the business users. And as business is going to change and continue to change, we had to make sure we look at different options. To address these challenges, we looked at moving to the cloud. As we all know by now, cloud gives you many different capabilities and many different flexibility in terms of what different data engines are available, how can I make sure that the silos of the data is removed. Today, if you set up your data lake, you get the ability to collect data from different regions, as well as how do you move data seamlessly from one region to another by replication. From a scaling perspective, there's auto scaling, right? So you can either add new servers, new capacity in minutes and hours, and no longer from what we've seen in the past to wait for weeks and months. All of this happens with the level of security and governance that no organization should ever compromise, right? So the cloud-first model makes sense, and we've been in the cloud, as McDonald's as an organization has been in the cloud for a long period of time. However, now, if you look at the different cloud providers, how do we make sure we are selecting the right cloud provider and a solution for us? So we went through the process objectively looking at and measuring different KPIs to figure out what is the right cloud provider for us. We measured across elasticity of how do we auto scale up and down, and looking at in a more focus of not just application integration or application development, but more from a data perspective and data engines available. The cost or the total cost of ownership is always a factor. There's a perception that cloud can be cheap, but if you leave your machines on and your servers on, cloud is not going to be cheap. There needs to be the right level of access, security, and governance set up as well for that. Maturity of the cloud provider. If you look at the different cloud providers, as we've heard through the keynote sessions, there's so many different services that AWS has launched, and it keeps launching. How do we make sure that you have a cloud provider that has the largest market share? Right? The time to implementation. Any change, any different change in the cloud can take time if it's not done right. But making sure that your architecture is agile is also part of your time to implementation. With all of this, we wanted to create a solution that is going to meet the evolving needs for the business, as well as create an architecture that we can evolve over the few years. Right? So, in here, there's no surprises here that we selected to move to AWS. Right? I wouldn't be presenting if it was not AWS. But we set our goal in terms of if we want to move to AWS and we want to create the next generation data and analytics platform for McDonald's, we want to make sure it's a well-architectured platform. What do we mean by that? Is we want to make sure that the storage and compute is separated by workloads. There are specific workloads where you need that to be separate. There are workloads where you don't need that to be separate. You want storage and compute to be get together. So how do we make sure that the architecture is flexible in addressing different workloads? We talked about one of the challenges we had was related to self-service. And the key word over here is self-service enablement. The enablement of self-service is driven by not just making the data accessible to the end users, but also what tools can they use for self-service. If you look at the new set of tools, there are a lot of new tools that are created and born in the cloud, if you will, right? They work much better than the legacy tools that are still catching up to how they would work in the cloud. So considering that. The third item was related to governance and data quality, which governance, data quality, and security is standard across any organization, making sure you're compliant for different reasons. For PII, how do you encrypt your PII data? What are the levels of encryption and options available? Right? The fourth one is one of the ones that I really like is as your data is going to keep growing and your user base will keep growing, how will they know, how do they search for the data, and how can they retrieve and get the right data? That leads to the whole aspect of making sure that you have a metadata catalog, and you can access and get the right data that you need, and the ability to search for the data and retrieve the data that is required. So with all of these capabilities in mind, think about what would that platform look like? So here's how this platform for McDonald's comes to life. If you look at from left to right, what we have is a whole bunch of different data sources that we get data from. We have batch data sources, which come in as files. We have real-time data that come in, and all of this data gets stored and captured in our global data lake. And the data lake is organized in three different ways for us. We have data that gets collected as the raw data that comes in. We also process the data. We have outbound data buckets, and then we have obviously the data that we archive in our data lake. Once we have the data lake, we look at our workloads in three different patterns. There is obviously the first one being operational or known workloads. These workloads are where the pattern for the data access is completely defined, and I know how the data is going to be accessed for my system. For these workloads, we use a combination of a big data processing through an ETL tool as well as EMR Spark and store the data in Redshift. The second category of the workloads is related to self-service workloads. This is where I don't know what the users are going to do or how they're going to access the data. Right? So for them, we want to go on the path of using a combination of Athena as well as the Glue data catalog, which retrieves the data from the data lake. These workloads will continue to change, and they address the needs for users who are just more exploring the data. They don't know what they really want to do from the data, and they still want to just have the potential to crash your systems. Right? The third set of workloads is related to your data science group. That data science group has many different flavors in how we support them. There are workloads that can run just basically purely on EMR and Spark for our users, and we let them do that. There are workloads that are applications for analytics that run on bare-bone EC2 servers, and we will install them and have them get the data again from the data lake. We are also exploring the option of using SageMaker, where the pre-built algorithms are already available for the users, and they can process and use any of the pre-built algorithms available. So as I mentioned, one of the key components for this architecture is really the data lake, right? So let's take a deep dive, a little bit of deeper dive on how the data lake is structured for McDonald's. So as I mentioned, there are 3 different layers of the data lake. The first one is the raw layer, or the inbound layer. This is where we capture the data the way it comes in. We don't apply any business logic or business rules. This helps us go back to the way the data was received by the systems, and also we also organize them either by source systems or by the subject areas that we would call them. The next layer then goes into creating a process layer where we apply business rules and have metadata files to enable self-service for them. So we also have the data definitions around them and not just the pure data, right? Again, over here we have the data organized by subject areas as well as the source systems from which we receive the data. And the third layer is then really looking at how is the outbound data set up. The outbound feeds are really what McDonald's shares data with third-party applications and vendors. This is where we share the data through the S3 bucket that we have set up for them. What this also helps us do is isolate the area in which they are going to go and which data set they're going to access. So I can set up permissions and security at the folder level for them to access the data. Right? So why do we set up a data lake? What are some of the benefits of the data lake? If you look, from a data lake as a concept really just helps to store and consolidate your data in one location. Now, for McDonald's, what happens is we use different AWS regions for Europe as well as for US. What that helps is, as I can collect the data from different regions, I can also seamlessly replicate the data to the global region in US. Right? That addresses our problem of data silos. How do we overcome that? It's through the setting up of a data lake. The data lake also helps us separate our storage and compute. And with that, what we can do is, as the data is stored and processed data, or the different shapes of the data that is available, it helps us put different data engines on top of the data lake. So I can put a Redshift, I can put an EMR, or in the future, I can put any other machine learning or AI services, or Athena as well. And I think that to us is the key differentiator of how we look at from traditional data warehousing to what I call data engineering, and how McDonald's is moving to the whole model of looking at it more from a data engineering perspective. One of the other things that we talked about was Redshift. Redshift is one of our data engines that we use to do our BI and dashboarding today. The workload that we run in Redshift is global. We do run our global processing. Everything that runs for different markets, for dashboarding and reporting, does run through that. One of the things that we as McDonald's have done is, as part of the migration to Redshift, we have helped improvise and talk about, and we will talk a little bit more about the different features and functions in the roadmap for Redshift. So that's been somewhat of a McDonald's contribution as well in automating some of, and I know Vidya is going to talk a little bit more about that, so I won't go into any detail for that. But here what we are looking at is we separate, again, our unplanned and unknown workloads from Redshift. So that way that we reduce the risk of how it's going to perform, right? And now, since cloud and Redshift is evolving so much, in the future, we may not have to do that. And that goes back to making sure we still have an agile architecture as well. Right? So with that said, what was our end result? So if we look at what we started with, the different challenges we had, now they are addressed by setting up one integrated global platform, which allows us to collect data from different regions, consolidate, store it, and keep it in a data lake. It gives us the flexibility of putting any data engines that we want. I can scale up and scale down in minutes and hours instead of weeks and months. And the reality is this helps McDonald's to be more data-driven and enables faster business insights and growth, right? While it seems like that we have accomplished a lot with this, there is more that needs to be done. We have just migrated to AWS, and if you look at everything that's changing in the cloud, we're just getting started with the journey in the cloud now. There is a lot of optimization that we need to do. There's a lot of different services that come out in the cloud. How do we go more serverless? How do we make sure there is more transient processing of application and the data, right? You truly are not going to get the advantage of cloud until we start building more automation around deployment of our products. And going back to fundamentally how we change in terms of how we do data from traditional data warehousing to data engineering, we want to start thinking about our data as data products, and how do we deploy more data products instead of deploying just a report or an ETL job, right? The last item also is to talk about is chargeback. With cloud, you have the ability to exactly figure out by utilization who's using what from which different line of business. Making sure we create a chargeback model which is based on actual utilization and not just a flat fee that gets charged to any department for just using a platform. That's going to be the next items for us to talk about. With McDonald's being more data-driven and the goal of being more data-driven, we feel very confident that with the AWS services, the solutions, and the products that we have, that McDonald's is set up to continue on the path of being more data-driven. With that, I'd like to pass it to Vidya to talk about the new features for Redshift. Thank you.
Thank you, Abhi. So I'm Vidya Srinivasan. I'm the General Manager for Redshift. And I'm going to talk about some of the things that we've done this year, some exciting features that we had a lot of fun developing, and also maybe start off with some trends in analytics. But before I get to my section, there were a couple of things I just want to point out. Abhi gave us a really nice view of the journey that McDonald's took. And I think if I look at this year, I talk to maybe 10 customers a week. There's almost nobody who's not trying to get to a data lake or optimize their data lake. It's a fact of life almost that for analytics to evolve, customers have chosen to expand from having just data warehouses and just one set of databases to a data lake type setup with multiple choices. So the slide that I liked the most of what he presented was this almost like a reference architecture where it represented the thinking within McDonald's about how they were going to think about the lake, what kinds of applications were going to use different engines. And I think everybody needs to figure that out. And with implementations being done at scale, like McDonald's and others, I think the value for other customers is really to get the best practices, because those are the things that are emerging. And with more and more of these implementations, hopefully these best practices can help you with your own journeys just move a little bit faster. All right. So with that, let me go in. So I joined AWS in 2012. And when at that time, we just launched Redshift. And this was our analytics portfolio at the time. There was just EMR, Redshift, S3, and we had data pipeline for moving data. And this was the broadest portfolio of anybody else at the time. And if we looked at what customers were doing, it was fairly what I would call traditional analytics at this point. It was stuff like ETL was done nightly. IT teams still knew who were the people who were allowed to go and query, which is not the case anymore. Anybody can do anything. And so there was a trusted group of individuals using the systems, and the systems themselves were fewer in number. And the workloads were pretty predictable. Now, fast forward to 2018, and we've grown quite a bit. And we are still the deepest and broadest in terms of the number of services available to perform analytics. And what I mean by that is if you look at our existing services, let's take EMR, for example. We went from having just a single engine to 7 engines. With Redshift, we've done hundreds of features just in the last 2 years. So we continue to do that. And we've also added a lot of new services like blockchain and SageMaker and many other things, all based on customer demand, things that we hear from customers like McDonald's and working through POCs, etc. So things have gotten quite a bit more complex. And there's a reason for that. And that all goes back to what customers are doing with their data and why there's a need for such a proliferation of engines. So the first trend that I'd like to talk about is just the growth of data itself. So we estimate that data grows about 10x every 5 years. And I can tell you from being a provider of a data service that this is an average customer. A lot of customers grow even faster than that. And if you think about data platforms, they end up living for about 15 years. Now, if you think 15 years seems like a super long time, just think about how long you've had that Teradata box in your company, or the Oracle server, or any of these core data engines that you've used for driving your enterprises. They do tend to stick around for some time. Just multiplying those two, you get that you come to the point that you have to have a platform that can scale 1,000x for you to have a platform that can support your future needs. So it's a pretty significant ask of a platform. So that's point number one. The second trend is there are just a lot of tools available today. It's hard to believe, but 4 years back, there was no Spark. Today, it's such an integral part of what we do. 8 years back, there was no Elasticsearch. So there is just this huge abundance of tools and technology being developed today. It's really the golden age for data. I've been in databases for a long time, and this is the most fun I've had. So, and 2 years from now, there's going to be Spark Junior, right? Something else is going to come out. And that tool, you're going to have to go figure out, how do I use it? Do I need it? Am I going to be left out if I don't use it? We will have one more service to add to our portfolio. We'll all be employed. It's all good for data. But this is going to happen for some time until we all stabilize, if we ever do. So that's the second trend to take into account. And the third thing is slightly more complex. It is to do with the people who use the data. We went from having a set of people who are experts in SQL, who knew their stuff inside out, who could optimize their way out of any kind of requirement, to just opening up data to executives, to analysts, to data scientists, to anybody in the company, literally. And this is a good thing. This is what we want. You really want to empower your folks to go and get value from data so that they can make better decisions. And pushing down analytics is an amazing way to do it. We do it at Amazon internally. That's how we run our own businesses. So it's a good thing. However, this complicates the process of ensuring that the data that you have is secure, and it complicates this whole ecosystem. How are you going to keep all of these things secure and accounted for and clean and managed while you still have to open up everything for varying needs? So it just complicates how you put together all these different systems. And I mean, Abhi was talking about flexibility or agility in architectures. Part of it is to accommodate requirements like this. So when you think about selecting a platform or going after a solution, here are just some of the things to consider. One is around flexibility. You just want to be in an environment that has open APIs and open standards, so that when the next set of tools show up, you don't have to go redo a whole bunch of things. The second thing is choose a platform that's going to give you the choice you need. Nobody I speak to tells me that they know the use cases that are coming next year. Everybody says, OK, I know this is coming first quarter. I'm sure there's going to be 10 other things behind it. So your use cases and what your business is going to ask will evolve over time, and it's good to be in a place where it'll just give you the choice. We talked about scale. You have to be prepared for massive scaling. That's just how it goes with data volumes growing. And the last thing, security is just table stakes, right? That's what you need to even stay in business. OK, so that was about the trends. So with that as background, let me jump into Redshift. So we focus on these 4 things. And it's pretty much what we've always focused on for Redshift. We want queries to go very fast. We want an individual query to run very fast. We also want the throughput of the system to continue to improve over time. We want the system to be super easy to use, preferably not managed at all. And of course, we want to continue to scale and be secure. Having been the first cloud data warehouse, we have the benefit of having a lot of customers adopt the platform in production. So here are some of the customers who use us. Here are some more. Here are even more customers who use us. So Lisa, who actually made these charts for me, must have been inspired by her ophthalmologist visit. But anyway, the point here is just that when you have a lot of customers, what it really means is we've seen a lot of workloads. These guys fall into different verticals. They come from different geographies. And if you're out there thinking, oh my God, what I'm doing is unique and wacky, chances are you're not. We've probably seen 100 of those, and we've had to do something to make them go better. And so that's just the advantage of scale as a customer. As a provider of things at scale, I wish I didn't have to deal with some of these things, but you don't have that option. So it's been just an explosion in the use cases that we've seen. And the requirements, as a result of that, have also changed and evolved over time. So let's see what we've actually been working on. So just since 2017 reInvent, so just in the last year, we've announced about 220 features or enhancements. Now, not all of these are big features. I've highlighted some of the most significant ones. But every single one of these features has come in as a customer requirement, either through our existing customers or prospective customers when we're doing POCs, or even just people complaining about Redshift on the internet through Twitter or other forums, right? So everything comes in through somebody having a real need. Now, what we don't talk about, what we don't publish, is all the stuff that we have to do to just keep the system running and keep things operationally stable. Things like restarts. What you see here is just a trend chart on restarts. These are fleet-wide numbers. So across the board, if I look at how many restarts happen in a week, we've seen sort of a 7-fold decrease just in the last, since the beginning of the year. But then there's been a lot of improvements to time it takes for a restart. There have been improvements to time it takes to provision a cluster. So these are all the operational things that go underneath the cover. Lots of engineering goes underneath the cover, even just to stay still, because the fleet keeps growing at a pretty rapid pace. And then it takes even more work to make them go faster. This was actually one of the interesting learnings for me personally when I came to the cloud. It's just, there's so much work to stay still. It's a pretty interesting place to be. Okay, so let's talk about performance and speed. I will first say that we have been obsessed about performance this year, more than any other year. It's always been important, but this past year we focused on it quite a bit. And here are some of the results. So what you see here are fleet-wide numbers. So these are numbers we compute by measuring performance across the entire fleet, across all the regions aggregated. So we saw a 17x improvement on repeated queries, a 10x improvement to bulk deletes, 3x on single row, and 2x for commits. As someone who's been in databases for some time, I think these are very impressive results to achieve in just a single year. And if we look at, there are just numerous things that went into making them happen. There wasn't a single magic bullet for this thing to happen. There were just lots of changes across the system that we had to put in place. But the nice thing is the numbers here are real numbers. These are the things that Redshift customers run today, and we can measure. The way we went about doing this was not, there's no coincidence in how that happened. What we do is we look at fleet-wide metrics on a weekly basis. We aggregate metrics on a weekly basis. In fact, we use Redshift to do all this analytics. And we dump all the fleet data, and we say, OK, what are the shapes of queries that people do? What is the wait times of queries, average data size that gets accessed, things of that nature, and then figure out what can we do. So every week, we pick 1 or 2 things that we want to go work on and get them implemented. So that's kind of how we go about making these changes. And as an engineering team, this is a very exciting thing to do, because you have so much visibility into real improvements that will benefit customers, and some very interesting engineering challenges as well. So from all that work, so here is a quote from Cookpad. They are a customer of ours from Japan. And they saw a 500% improvement in commit times over 10 months, even as data was growing over that time frame. So it's really heartening to see these sorts of improvements. So we said, OK, so we've seen that the fleet is getting better. What has that done for benchmarking numbers? So we just tried that. This particular chart shows the benchmarking numbers from the TPCH benchmark. So for data warehousing, as most of you are aware, there are primarily two benchmarks that people look at. There's TPCH and TPCDS. And this is a 3 terabyte TPCH benchmark, and we had about a 3.5x improvement over a 6-month period based on all the other changes that we put in based on fleet data. I have more benchmarking numbers, but let me just give you my view on benchmarks. So benchmarks have been around forever. We've seen them for ages. And benchmarks were really created for a time where vendors couldn't really get an accurate view of what customers were running. It was not possible for vendors to know exactly what were the workloads that customers used on their systems. And customers also did not have the luxury of trying many different vendors before buying, because imagine if you had to try a bunch of vendors, you have to go through a procurement cycle for all of them, and hardware had to come in. They were just incredibly long. So benchmarking were a good way to compare vendors, because at least you had a standard workload, and you could say, how did the standard workload do on each of these systems? Today, the world is entirely different. Today, as a customer, within this afternoon, you can spin up 5 clusters for 5 different vendors, put your own workload, and have a sense for how things are going. It's a very easy to do that compared to what people had to do earlier on. Similarly, as a vendor, it's easy for me to know what customers are actually doing on their system in the cloud. So benchmarks are quite antiquated, but in spite of that, what we've seen this past year is just a number of blogs about benchmarks from vendors, comparing Redshift to themselves over and over again through many, many different outlets. And some of those claims were really off, because we also have bake-offs and other avenues to understand what's going on when we compare ourselves, and they were just really off. So we decided to go ahead and run it ourselves, just so we can clear up the FUD in the marketplace and clear up misinformation, because it's being used more to spread misinformation now. So we did run Redshift against 3 other vendors. And what we found, and this was the TPCDS and TPCH 3 terabyte data sets with the systems tuned. And what we found was Redshift performed the best on TPCDS and came in a close second on TPCH. Now, I've been in other companies working on databases where you would have entire teams just optimizing benchmarks, the benchmarking queries. That used to be done. It's still done. We don't believe in doing that. Our approach is we're just going to go after the real customer issues that come in, the things that we see in our fleet. If it helps the benchmarks, that's great. If it's not, it is what it is. Now, if you take the same workload, the same benchmarking workload I showed in the previous slide, and you apply the cost, so that the comparisons in the previous one were all based on hardware equivalence. Now, if you put cost into the picture and say, if I had to run these for a year, how much would it cost across these various systems? This is the comparison. So Redshift came up to be about even 7 to 8 times cheaper than some of the other options out there. So if you combine the advantage in cost with the performance advantage, it's a pretty compelling proposition. And the numbers we used here was a 1-year RI for Redshift and public pricing with whatever discounts were applicable for the vendors. And in fact, with Redshift, you can also buy a 3-year RI, which is a 75% discount, which would take the price down much further. All right, so that's on benchmarking. So let's jump back into fleet telemetry. One of the requirements that we hear from customers is around concurrency. Customers have said, hey, we want to use Redshift for ad hoc use cases. I just want to be able to throw another 100 users, 1,000 users, and just not worry about the system. So we said, OK, let's go take a look. Let's see what's actually going on. And what we found out was 87% of customers did not have any queue wait times. And when you don't have a queue wait time, it essentially means you don't have a concurrency issue, because we are able to process things at the rate at which it arrives. Now, the rest of the 13%, what we noticed was they were really queuing up largely in 10-minute chunks throughout the day. And in the mornings, it will be more, in the evenings, it will be more, and then it goes down throughout the day. But they were typically in 10-minute bursts. So we wanted to build a solution to address this concurrency use case, the high concurrency use case. Last week, we announced this new feature called Concurrency Scaling for doing exactly this. Currently under preview. What concurrency scaling does is when there is a queue in the system, when there's queuing, we automatically spin up another cluster, another set of clusters, and divert the queued up queries to that other cluster. The queries get executed in the secondary, or let's just call them concurrent clusters. In the concurrent clusters, the results come back to the master cluster, and the results go back to your endpoint. So there's no change to the endpoint. Everything is still through the leader node, and your application does not change at all. The way you would use this feature is go into your workload manager and click a box saying, hey, just make sure that you spin up other clusters or use concurrency scaling if there's queuing in the system. So a couple of things I want to point out here. The other clusters get attached to the primary cluster. The concurrent clusters get attached to the primary cluster within a matter of seconds, and queries start going there and running immediately. You do have to pay for the query on the concurrent cluster, but you pay by the second. So it's just the number of seconds that the query runs on the concurrent cluster. The second thing is you don't have to wait for any rehydration on the concurrent clusters for this to work. Because the time that there is a burst in activity is in short chunks, it's not very useful to take the time to rehydrate data before querying. So this feature works by just querying even before data can get into the system. So instead of going with rehydration, what we've done is used alternate techniques to really speed up the queries, things like adding a caching layer, pushing down predicates, scaling out scans, many other ways of speeding up queries that doesn't require things to get rehydrated, because that's just going to take time. And when you have a sudden peak, and if you want to keep costs low, because the minute you start rehydrating in a cluster, you're going to start paying for it. If you want to keep costs low, this is a better way to go. The performance numbers have looked really good. So this is how the scaling looks with our current code base. Of course, this is going to keep improving. So what you see here in this graph is the gray bar is the primary cluster. That's the throughput of the primary cluster. And the orange-yellow bar is the throughput we get from the concurrent clusters as we keep adding more concurrent clusters to the primary cluster. It's not quite linear scaling, but it's pretty close. So you can just send a lot of queries and have Redshift take care of offloading them to other clusters as it sees fit. The other important thing to note here is we are going to offer 1 hour free of concurrent cluster usage for every 24-hour usage of your main cluster. Now, this maybe doesn't seem like a lot, but remember the burst periods, the periods when activity peaks don't come in huge chunks typically for the average use case, right? Not every workload is the same. Because of the 10-minute burst throughout the day, based on the current workloads, 97% of our customers will have to pay no more to use this feature. It'll all come under the current costs. All right, so that's our concurrency feature. Let's move on to simplicity, ease of use type features. Very excited to launch Elastic Resize. We went GA with this a couple of weeks ago. I forget the exact date, a few weeks ago. And we've already seen hundreds of these take place. So with this feature, we basically bring down the time it takes to resize a Redshift cluster from several hours to a couple of minutes. And the primary reason we're able to do it, have such a dramatic decrease in time, is because the resize here is happening in place. So when you add 2 nodes, we basically add 2 nodes to an existing cluster. We don't create a new cluster and just move the minimum amount of data to that cluster. So what are some of the use cases? It's been interesting to talk to customers. They've used it, obviously, in ways we didn't imagine. So the first thing was, well, for folks who are thinking about resizing because they think they're going to get a lot more data in a month, and they just want to resize to the, to give them, they don't want to resize again within the month. Well, all those things can change. You can wait to resize just before you expect to get your data. The other thing we're also seeing is, let's say you had a month-end processing ETL job, a really heavyweight job coming in, and there's a very tight deadline at 4 a.m., 3 a.m. that it has to get done. We're also seeing customers resizing up to get the job done with more headroom, and then resizing down after the job is done. So these are some of the use cases that we see emerge from this feature. We also launched the Redshift Query Editor in October. So the requirement here was, while there is a plethora of tools available for SQL, submitting SQL queries through ODBC, JDBC, customers don't want to install anything. They just want an experience that just says, I just want to open a browser and be done. And this basically gives you the open a browser and be done experience. We, in fact, borrow the look and feel of Athena so that people don't have to learn it again, for those of you using Athena already. And it has the standard stuff like SQL highlighting and autocomplete and things of that nature. So again, do it from the Redshift console. It's part of the AWS management console. As long as you can get in there, you can submit a query immediately. We launched Redshift Advisor in July. So think of Redshift Advisor as best practices in code for your workload. So over the years, we've written many best practices blogs, we've done webinars, but what we see in practice when we go talk to customers is it's hard for folks to absorb all of that because you also have so many other things to deal with and figure out how to apply that to your own workloads. So what the advisor does is we have a program, almost like a little monitor, that sits on the cluster and says, okay, what are the things that these guys could be doing a little bit better to optimize performance? It'll find out all the opportunities to do so and publish it to the console itself. So things like, hey, maybe you should be compressing it using this algorithm when you import this table. Things that could just make your cluster go a little bit faster. So it provides all this in the console. I think we have about 11 now, and we will continue adding more advisors to it. And the goal really is to evolve this to a point where, right now we are saying, okay, these are the things we'd like you to do. Wherever possible, we'll give you a button where you say if you click it, it'll just do it for you. But the goal is, as there's more confidence built on both sides that this is exactly what you want done, it'll get automated, meaning you can maybe opt out of getting advice, but as a default, these things will just get optimized for you in the background. Another feature that's coming soon is the automation of the distribution key. So as most MPP systems do, or I think all MPP systems do, Redshift uses a distribution key to enable tables to have the opportunity to do co-located joins for performance and such. So it's not always obvious for folks to pick the right key as a distribution key. So to take that away, what we are doing is having this automatic distribution feature where every table, when it's born, it starts off as a small table. So we're going to take that table and put it in all of the nodes because it's small and it just makes it better for performance. And then as the table continues to grow, we're going to move that to an even distribution style where it gets distributed across all the nodes in the system. And then as it grows even bigger, we'll actually pick a distribution key and assign that across the nodes. And this feature is one that will be delivered in part, and it's going to come out in the next couple of months. The one after, so if you now that the distribution key is taken care of, there are really only 3 other things one has to do within Redshift for maintenance. One is analyze. So analyze operation is just to collect statistics on your table so that we can be smart about query plans. So again, affects your query performance. The concurrency setting, this is how you set up your workload manager. how many queues you choose to use, what is your concurrency setting for queue, things like that. And the third one is vacuum. Vacuum is a process where you can compact your data on disk and resort the sorted columns. We're making all of these things fully automated and background operations. Again, all of these are going to go out in stages. Auto-analyze is already GA in some regions. It hasn't rolled out to every region, but it's already GA in some regions. We've been a bit astounded by the auto-analyze automatic adoption. Nobody had to do anything. It just gets adopted because tables aren't analyzed. So just, I think, the last 24 hours, we saw that in a very small region, we analyzed or auto-analyzed over 500,000 tables. I can only imagine what happens in the larger regions. So there's lots of unoptimized stuff out there, more than we had anticipated. In the concurrency setting item, what essentially will happen there is all you do is create one queue and send all your workload to that, and we figure out how to partition it, how to get it set up. And you can imagine that when we use that in combination with the concurrency scaling feature, it gives us a lot more, ways to get the queries executed faster. We can spin up more clusters and get it executed on other clusters as well. And on the vacuum delete is out. Vacuum sort will be out next. Also want to announce support for stored procedure in the coming months. This has been a big ask from customers. Sorry it took so long. Big ask from customers for migration. Just eases migration quite a bit. And of course, we are going to support PL, PG-SQL. We are a Postgres-based system, so that's what we're going to go after. All right, let's talk about scale, or really, it's really about data lake. So in the data lake area, so it's the fact that people are going to use many tools to operate their analytics. And we launched Redshift Spectrum last year to specifically address this use case. We said, hey, we really want to make it easy for the data warehouse user to also go and grab data from their data lake and do all the wonderful SQL stuff they're used to and get good performance while accessing that data. That was the goal of Spectrum. And we see a ton of adoption for it. We also see that, so we continue to invest in Spectrum and making it faster. One of the things that's coming for Spectrum is a caching layer for it, the Spectrum Request Accelerator. It's going to have a significant impact on the performance there. And we've also announced support for nested JSON for Spectrum, which helps with part of the data that's already stored in S3. We announced support for ORC, and that list just keeps growing as customers tell us that they need more stuff. Apart from that, the other thing with this lake architecture is customers want, one of the use cases that we see is, data starts off in S3, it gets maybe processed through Spark or Hadoop or one of those, some engine that they use. And then it gets ingested into Redshift. And then they do lots of complex query processing within Redshift, essentially to do ELT type processing. They transform the data in Redshift because SQL is nice for that. And after they've mangled the data and put it in a form, aggregated form that people can actually use, they want that to go back to the lake so that Spark can pick it back up. And to essentially facilitate this use case, we added support for copy from Parquet, because Parquet is sort of a semi-standard now for storing data in the lake. And we're also going to launch Unload to Parquet, just to have this lifecycle complete. And we're doing more things of this nature. Essentially, we want you to be able to build a lake and have Redshift be a seamless part of that lake. And the muckiness of dealing with moving data around, dealing with the difference in formats, dealing with security, dealing with cataloging, all of these things are going to be made much faster. Directionally, that's kind of where we're heading. And I'm just talking to you about individual features here, but that's sort of the goal that we're heading towards. In 2 slides, I'll talk about one other feature that's entirely to support this. So talking about security. So for Redshift, security was, even when we thought of Redshift as a service way, way back, security, we said, okay, security has to be a part of it. This is an enterprise data warehouse. It just has to be a day one feature, and it has to be a part of the thing. We're not going to have a non-secure version and charge more for a secure version or do any such thing. So we had security built in day one. So data was encrypted at rest right from the day we launched. And at rest is data on the disk, data on S3, data on the swap. Wherever we store data, we encrypt it. And of course, data in motion is also encrypted. The compute nodes of the cluster where your data actually resides is in a separate VPC than the leader node. And so that way, your tools cannot even get to the compute nodes or the data. And only the leader node resides in the customer VPC. And of course, we have all the other stuff around auditing. So every access to the API is logged, it can be audited. All of this goes to CloudTrail. And so we have a whole bunch of this. Just a few of the compliance things that we support, but we pretty much support every compliance that I've heard of from customers as a requirement. The next step for us with respect to security is to go back to supporting the data lake security model. So Andy announced yesterday this new service called Lake Formation, AWS Lake Formation, which essentially allows you to go faster with building and implementing and optimizing, managing your data lake. So if you think of it, the way we think about this is there's going to be multiple engines on top: Redshift, EMR, Presto, Spark, machine learning, whatever you want. And then there's data on the bottom. And we see that the security layer for the data should be in between these two so that you can define it once and have all the engines just pick it up rather than individually try to keep all the engines in sync, because that's going to be a lot more difficult. So Lake Formation is going to be the place where you define your security policies. And you say, okay, this is how I want to manage this data set. And Redshift will integrate with Lake Formation, and it will go through, it'll take the security policies that are defined there for its own operations. So that's the direction we are heading. As Lake Formation is now, I think, in preview, that'll GA at some point. But directionally, that's where we are investing as far as improving security. Okay, so this is for your phones, whatever phone you're using, because people take pictures and send back to their teams. These are the features that you should be communicating back. Some of the important things. Here, I mean, some of the smaller features, but important features that were direct customer requirements where there's deferred maintenance. People didn't want maintenance to be applied during their peak periods, maybe like December. December may not be a good time to get maintenance. So we implemented that. We also implemented a snapshot scheduler. So you can schedule your backups and not just take the automated backup policy. See, when we don't automate something, we have to automate something. When we automate something, we have to have a scheduler. So you can never get it right. So these are some of the important features. There are lots of places to learn more. One of the things I'll point out is we just came out with an ebook. That's the first link there. The Modern Data Warehousing ebook. And it's a pretty nice primer and quite well done, I would say. It's available through the AWS, our landing page link. Do take a look at that. You can also sign up for the beta for concurrency scaling feature if you're interested. There's a page for that as well. And lots of information about migrations and such. So thank you. So we have 6 minutes left. Do I really have 6 minutes, or should I get off before that? Okay, I have 6 minutes. Yeah.
I got a question regarding the concurrency scaling information. And it's regarding the I/O underneath everything. Does the other cluster work on the same data?
It does. It has the same exact view of data as. So the question was, in the concurrency scaling feature, when you have these concurrent clusters, does it work on the same data as the main cluster? The answer is it has the same view of the data as the main cluster. So all the if once you commit data on the main cluster, it can see it.
But do we also get more I/O during this time, or is the same I/O that we have?
You will. It's a brand new cluster, so
Get more I/O.
yeah, you get more I/O.
And this other cluster is read up for read-only operation or read-write? Can you do
Right now, it's read-only. The first version is going to be read-only, and then it's going to evolve. Yes. Yeah. Yes, sir.
A question on that data lake formation.
Uh-huh.
I understand that it got the logs and then ingest data sources.
Uh-huh.
Which AWS services are used to ingest data?
You mean the context of lake formation? So it's going to be an evolving set. The intent, of course, is everything that ingests data into AWS will have an integration into lake formation, because we expect that to be sort of a central repository to manage the lake, like an index for the lake. But there's going to be a timeline for when it will be done. I think so there's a small set of services that will be there on GA, and then others will add as time goes by. Now, if you have a particular service that you're looking for, you can either let us know, or you can let the lake formation team know, whichever way, and we'll make sure to take that into account. Mm-hmm. Yes, sir?
Yeah. This we have three challenges. Okay, I'm not sure if just they improve us.
Uh-huh.
It's replica data. As we learned before, right? Okay, Redshift do not have replica system, right?
Uh-huh. So concurrency scaling, think of it as a re-replica for all, from a mind. Yeah, because it gives you the ability to read the data in Redshift through a different set of hardware, which is what re-replicas do. So, but it goes through the same endpoint. The same endpoint is the primary thing. So it's not we don't call it re-replica because it's still different. But for all practical purposes, you do get the extra bandwidth that you would get from a re-replica.
How about like update performance or first time query? Okay, because that's three big challenges we have.
Uh-huh.
The replica data, first time query, based on the tests, it was kind of slow compared with the other solution. I think a second time with cache, the performance is pretty good. Okay.
Uh-huh. So sometimes the first time query is low because of the compile time for the query. The way Redshift system works, we actually compile your SQL query segments and cache it in our code cache, and then the second time around there's no compile overhead. What we are doing separately, I didn't have time to talk about this, is reducing the compile time for queries. So we'll still compile it, but the overhead for the first time query has been going down, and it's going to go down quite dramatically. Mm-hmm. I think there was another question, yeah.
This is kind of extension to the first question. So about the elastic resize.
Yeah.
Are the data being loaded to the new node that is being edited? Is that like it's going to same view from other nodes, or it's going to be a different view? Because if you go back to your slide, it has different number of square boxes. I was wondering if there was a reason for.
Right. So the question is, for elastic resize, is there going to be a difference in how? So this is an in-process resize, which is why we've animated it like this, but it will be fully balanced. So we're going to try to get it to be as balanced as possible. In reality, one might have like a little bit less data than the others, because at some point you can only distribute evenly to a degree depending on how many nodes you add or remove. But we will try to get it to be fully evenly distributed with the same distribution setup that you have currently, whatever disk keys you have.
So in both elastic resize and concurrency scale, is there any like a prioritization on which data to copy first?
Yes. On elastic resize there is. Here we copy data that is more used. We do keep track of data that gets used more often for querying than not, and that gets copied over first. That way the query performance doesn't suffer while rehydration is going on. In concurrency scaling, because it's not a rehydration based solution, that thing doesn't really exist. In concurrency scaling, we go grab the data blocks that the query needs.
So more use means more percentage use or more often use?
So we use a combination. It's not a pure LRU. We use a combination of, because you don't want to completely flush the cache just because you have a new query that has brand new data, right? So we keep track of both recency and frequency, and we have an algorithm that kind of finds a middle path.
Just one more last
Yeah,
question.
yeah.
So in elastic resize, it doesn't increase the concurrency of the cluster, right?
It adds, in concurrency scaling, it adds the concurrency of your Redshift cluster for all practical purposes. Maybe it was behind, huh? Okay. It doesn't add nodes, it adds clusters. So you add more concurrency by adding more clusters. Elastic Resize adds more nodes. So what it does is makes queries go faster. So this is why big ETL jobs will go faster if you add more nodes. Yeah. Yes, sir.
So we use Redshift a lot of times to slide data.
Uh-huh.
How much would you use time stream service?
Yeah.
The difference what we can expect?
Sure. So the new time stream service is largely geared towards these IoT use cases that send a lot of very time-sensitive data where you need to do some very quick processing. But it doesn't, it does scans and AGs. It doesn't do any joins. And the SQL that it supports is quite restricted. So Redshift is, I mean, there is a bit of an intersection, sure, but that is a purpose-built database to scan and AG things that arrive very, very quickly. Yeah? Concurrency scaling. Uh-huh.
What's the pricing going to look like after this hour?
After the hour, so you pay by the second based on the price, on-demand price of your main cluster. So whatever number of nodes you have there, the price of that. Per second, because we expect queries to be quite small. Yeah. Yeah. Yes.
Query about the McDonald's example, where you showed structured data, well understood operational queries, Redshift,
Uh-huh.
all ad hoc access was going via schema,
Uh-huh.
whereas I was expecting to see ad hoc queries on structured data, which they do on Redshift. I appreciate you might be just simplifying the point.
Right.
Is that right? And is that recommended?
So you know this is the McDonald's slide that he had. So to some degree, they did that just to make sure that when ad hoc, if there's a lot of ad hoc queries coming in at exactly the same time, it's not a rare ad hoc, but a very quick ad hoc, they were worried about concurrency limits that they might hit and overwhelming the cluster. Now with concurrency scaling, I think the options open up for them. Now whether or not they want to go revisit is completely up to them. But that was the motivation for going down that path. Yeah.
I have a question on the McDonald's example.
Mm-hmm.
This one where both structured and unstructured data sets
Yeah.
that go to the data lake.
Uh-huh.
I'm curious to know for the structured data, but also relational databases, was it moved to object storage in S3 before going back to like the relational storage and Redshift, or was it moved directly to like from relational to relational? So I mean that question clear. Yeah. So let me make sure I understand the question. What the question you're asking is when you put
The data in S3, were we migrating from a NoSQL or a traditional data warehouse, or?
What I was curious about, I think in your slides you showed sources that were both structured and unstructured, right?
Yeah.
I imagine some of the structured data sources might have been coming from relational databases.
Yeah, no, so the structured data that we get is really the files or the transaction data from the stores. That's the structured data. So it really just comes in as files.
Okay, so it is file-based.
Yeah.
Just
Cool.
trying to get a sense, I don't know you can even disclose this, but how big is your Redshift environment? Is that something private or?
Yeah, I think we have multiple clusters. So we look at it as from a global and a market perspective. And depending upon that, the size varies. So right now we have two clusters.
Too close.
Yeah.
Yeah.
I know it's really early, but when you guys launched Elastic Resize,
Mm.
have you noticed at Redshift that kind of making people like downtimes signing up and back up?
Too early to say. I don't expect it'll happen, but too early to say. Even if it happens, it's a good thing. I mean, I'm not saying I don't want revenue. It's like, it is that, I mean, they're paying for what they want, right? So I'm happy about that. Okay.
Cool.
Can I repeat?
Sure.
In the spectrum, just making the way back to write to experience Parquet,
Mm-hmm.
are we thinking just including Parquet in the unload command as a format?
Yeah.
Or you're planning on doing the create table as you can do that as well?
The unload command.
Or no faulting the CTAS thing?
Oh, I hadn't thought of that. Okay, we were thinking of unload, but that's a good idea. Okay. Mhm. Got it. Okay. Mm-hmm. Sure. Well, when they kick me out is when I leave. So.
Be happy tomorrow.
Well, I know that usually you guys cannot really comment on the details development.
Uh-huh.
You mentioned earlier that downloads to market
Right.
and
Uh-huh.
been working on for years, basically. Do you have a rough estimate if we can expect that more like early next year?
December, January. It's December, January. Yeah. Yeah.
Right, thank you.
Sure. Yeah.
More data link question in general. I mean, we deal with multiple regions, kind of like McDonald's was saying. We've got separate environments in Europe for GDPR purposes and PII
Uh-huh.
installation and stuff. When people are building their data lake, ideally you want everything in one place. What have you kind of seen from that? Are people just like dumping all the PII and putting everything else in there, or what's the best strategy to kind of still comply with the different compliance targets, but have one location where you can do all your stuff?
What we are seeing is people are creating regions within the lake. It's almost like a proxy of what you used to do in data marts and other things. Like we put it in individual monolithic systems and said that's how my walled garden works. Now they're creating all these different regions within the lake. Some are super highly managed. It has only super users who can go with it. The data is qualified data that everybody is going to use for sales forecasting and things like that. And then there are lots of sandbox regions within the lake that people can go and play with, and that doesn't have the same restrictions as a primary region does. I don't know if that answers your question.
So people are still, from what you're saying, people are still bringing that PII back to the U.S., for example, but they're just protecting it more stringently than they, might for a lot of the other data that's in their data lake.
That's what I'm saying, but I don't know if there are specific countries, things that come into play. I'm just not familiar with any, there's a specific restriction by this country that you cannot even move it. I mean, there are certainly things where you can't move out of the region, right? So those guys have to manage it within whichever sovereign state they are in. And what we end up having is to facilitate cross-region, figuring out what can we do cross-region to still help them get their hands around this data. All right, thank you. Yeah.